So today we're going to be talking about relative motion. What is relative motion? Think about this question. What does it mean to be moving? And how are we supposed to define motion in physics? Let's say that I'm driving at 30 miles per hour in a car on the Earth. The Earth is rotating at around 1,000 miles per hour. The Earth is orbiting the Sun at around 67,000 miles per hour. And the entire solar system is moving through the Milky Way at around 490,000 miles per hour. So how do we represent motion? We would say that I am driving in that car at 30 miles per hour relative to the Earth. Here are a couple of examples to explain. If a car comes towards you at 50 miles an hour and you are in a car driving 50 miles an hour in the opposite direction, it's coming towards you at 100 miles an hour relative to your car or your frame of reference. Let's look at another example. I'm inside a train moving at a constant speed of 20 miles an hour. You're outside the train watching from Earth's frame of reference. If I drop a ball, it's going to look like it fell down to the ground normally. However, you saw something different. When I dropped the ball was pulled down by gravity. The ball retains its forward motion due to the law of inertia, so you observed a motion like this. This concept is really important to understand for space travel. Let's say a satellite is moving at 17,000 miles an hour around the Earth. I'm inside a rocket moving at 17,060 miles an hour around the Earth, 1 mile behind that satellite. Since I am moving 60 miles an hour faster than the satellite, it looks like the satellite is coming toward me until I overtake it 1 minute later. Let's look at one more example. I'm driving on the freeway at 60 miles an hour. I throw a baseball through the windshield at 15 miles an hour. So the baseball I threw is moving at 75 miles an hour relative to the Earth. The baseball is only moving 15 miles an hour relative to the windshield and the rest of the car. What if I threw the baseball out the window at a stationary car's windshield? What would happen then? Remember that the baseball is moving at 75 miles an hour relative to the Earth. The stopped car is in the Earth's frame of reference, so that baseball will hit it with the full force of a professional pitcher at 75 miles an hour. Thanks for watching Relative Motion.